Okay, so in this video, we're going to look at how to create some common statistical graphs in R. Now, to get us started, I'm going to load the data set that we were using in the last video, which is actually already in my memory, but I'm going to go ahead and re-import that just to make sure it's nice and fresh. And we're going to resave this as data 2. And we're going to run our code, load our library, load our data. Now, you may remember from the last video, this data set has a combination of categorical variables that are coded as dummy variables and some numerical data. And we're going to be using that combination to create a variety of different graphs. Now, if you don't have this data set, of course, you can follow along if you use like the MT cars data set. That also has a group of variables that you can treat as categorical variables, such as the cylinders. You can convert to factors the same way we're going to convert some of our dummy variables into factors. And there's also a variety of numerical variables you can use in place of our numerical variables. So we're also going to remove from this data set the first column as we did in a previous video, since the first column of our data is actually just it's a household number variable. It's not really a variable. It's a stand-in for the owner's, the address location of the actual home. So it doesn't actually mean anything. So having removed the first variable, we're now going to factor the location variable. The location variable is listed as, in this data set, a number. In fact, we could just go look at the data set. And in fact, you can get a preview of it just by typing this in. But I'm going to go ahead and open it up. And so we can see that our location, there's at least 4 locations that are coded as numbers. And these are like, north, south, east, and west kind of locations. They're sub-neighborhoods within the community. So we don't want to treat these as numbers. We want to treat them as categories. And so to insist that R do that, we're going to factor these variables. So by factoring, essentially we're converting them into strings so that R doesn't recognize them as numbers, but treats them as these categories. So we're just simply going to specify the column name, and then we are going to factor that same column. Now, it won't appear any different if we were to look at the data. The data still looks like locations, except now they're over to the left of the margin because they're treated as strings, and not over to the right, which is where the numbers get displayed. And then we can actually make a table of our locations. And that tells us essentially how many counts are in each of our location categories. So they're pretty similar. Location 1, neighborhood 1 has a few more. Location 3 has a few less, but basically they're relatively evenly distributed. Now, if we want to make a bar graph, we can use base R functions, or we're also going to use ggplot functions later on. But there are some basic plotting functions in base R so that you don't need to have any particular packages. One of them is the bar plot, and we can make a bar plot of our table. Now, the bar plot is very basic. It doesn't have any axis titles, doesn't have an actual graph title. So if we want to add those things, we can do that. Capital. So main would be the name of our graph. So number of households in each neighborhood, comma. And if you find that you want to be able to see your whole thing, you can hit enter after any comma, and it will indent and continue the code. XLab, the label for the x-axis, we can call neighbors, neighborhoods rather. And Y-lab, we can call counts. And colors, we can make them, the color, we can make a wide variety of choices. I'm going to use dark green. And then horizontal equals false. This will give us the vertical bar graph. We can certainly change this if we want to a horizontal one if we'd like. And so now we have axis labels, we have a graph title, we've changed the color of the graph, and of course, feel free to experiment. Maybe you would like a true horizontal graph. So then the bars will go that way. Now, the nice thing about R is that it will save your plots for you in the display so that you can return to them later on by just simply looking at your previous plots. If you want to save your graphs, then use the export tool here, and you can save as an image, you can save as a PDF. Now, sometimes the copy to clipboard I find doesn't really work as well, but you can always save the graph into a file and then return to it, import it into another document later on. And you will have options for where to save it and what format to save it in. So this is our basic bar graph. Now, we'd also like to make a basic histogram. So we do have some numerical data. So we're going to look at that. Histogram, the debt data we were calculating statistics on last time. So now we're going to make a graph of it. This is just a one variable graph. So we don't have to specify a Y variable or anything. Household debt. XLab is debt amount in dollars. YLab is relative frequency. Color, dark magenta. And again, there are lists of which kind of colors you can have. Feel free to experiment with them. Frequency equals false. So this will deter the frequency function here will determine whether you get counts or percentages. And then if we run this, again, these are relative frequencies. If you specify this to be true, then it will give you counts instead. But this is our histogram of household debt. Now we can use the same data to create a box plot. So data, debt. XLab, utilities per month in dollars. YLab. Oh, there's no YLab. Color, let's try orange. Border, let's make it brown. And horizontal equals true. And notch equals false. So we can go ahead and look at our box plot. So this is your standard box plot. It's colored in orange. We have brown borders in this example. If we wanted to make it vertical, we could say false. And if you wanted to have the notched look, you can set that to be true and get a slightly different look for the box plot. It just emphasizes where the mean is at, or the median is at. Now, we looked at a histogram earlier, but we can also, if we prefer, look at a density plot with a nice smooth curve. Whoops. Kernel density of debt. Now, some plots in base R are meant to be very basic, and then you can add layers to them. And this would be an example of that. So we've plotted the kernel density, but then it was just the curve itself. You can fill it in to make it stand out a little bit more by using this polygon function, and it will overlay on top of this. Again, here I specified the color of the interior to be red and the border to be black again. You could also, of course, overlay the kernel density plot on top of the original histogram, and then you would have both the histogram and the smooth curve. For that, you would have to make sure that you're doing the relative frequencies and not the counts for the histogram. We can also make a stem plot. Now, there's a lot of data in this this data set that we're looking at, and so the stem plot can be quite overwhelming when you have a lot of data. So I'm going to plot this, but then I'm also going to look at one for the MT cars, which has a little bit smaller data set to work from, because this data has 500 observations, and so the stem plot will be a lot. But we're going to run it anyway. Now, the thing that happens with the stem plot is it doesn't plot on the plotter. It's a stem plots have the original data, and so it actually plots as a text plot. So here's our key that explains there's 3 digits to the right of the decimal point is 3 digits to the right of the bar. So I had to round this essentially to the thousands of dollars. But it does produce a very nice stem plot. We could also make a stem plot, as I mentioned, of something like MT cars, MPG. Again, this is a smaller data set, and so the stem plot will be a little more less involved, shall we say. And again, here the decimal point is basically at the bar. So this does output to text only. So if you wanted to copy it into a document, you would copy and paste the text from the console. And then the last kind that we're going to make before we move on to ggplot is just a simple scatter plot. If we want to compare two variables to each other, oops, quotes. And then the PCH is going to specify what kind of dots we're going to get, what kind of on the plot. Now there's a list of them that you can look up for the R documentation of what all of the individual codes stand for. There's like 26 of them or something, but this is just a simple dot. You can also, of course, add things like color commands and things like that in order to make your graph a little bit more interesting. Now we're going to move on to ggplot. Now the nice thing about ggplot is that there is a nice cheat sheet for it so that you don't have to remember all of these things, and you can quickly refer to the graphs. And once you get used to the functions in ggplot, then it actually is awfully straightforward in terms of how to build a plot. Now, the general idea behind ggplot is what they call the grammar of graphics. And essentially, you're going to build a graph from the ground up. So we're going to start with specifying our data. And then the aesthetics essentially is going to include which variables we are going to be using. So to start with, I'm going to be using X is debt and Y is utilities. And then if I want to plot a scatter plot, I am going to add on that I want to plot the graph as a point. G on point is going to be a scatter plot. And if I go ahead and run this, then I get a similar scatter plot to what I had before. Now, I didn't specify things like titles or things like that, but it does automatically add axis titles from the variables that I pulled out of my data set. Now, if I want to create a box plot, let's say a comparative box plot, I can do that very easily. I'm going to specify my data. I'm going to specify, so the first data is always the same. The second one, for instance, would be the name of the data set that we're pulling our data from. Data when I imported it this time is the same as the data that I imported in the last video. So you can use data or data2 if you still have this data set in memory. I just wanted to specify that it's data equals and then the name of the data set you're pulling from. Here we would then have AES, and then if you're specifying them in order, you don't have to specify X and Y. Although I usually do, just because it makes more sense in my brain to do that all the time. And then box plot geom box plot. And if I run that, then again, I get a box plot. I can x equals location, y equals det. Oops. There we go. So if you just specify location, if you just specify a categorical variable, it won't necessarily group them into categories for you. But if you specify group, then it will take your locations 1, 2, 3, 4, and it will it'll create separate box plots for each thing. If you just specify det, it'll only create one such graph. Now, we can also create other kinds of one variable plots. So we looked at the x equals det. And then we can make a box plot. And so we saw that earlier. So if you want to specify y equals det, then you will get a vertical box plot. If you specify x equals det, then you'll get a horizontal box plot. If you want a histogram, then you use geom histogram. And if you want a density plot, then you'll get a density plot. And if we want to add some details, for instance, so if I want to make a histogram of my det data, but I want to adjust some things, so I can modify the bin width. I'm going to try 500. Feel free to experiment. I'm going to change the fill to blue. And then I'm also going to add some labels. So the title is going to be household debt. X equals debt in dollars. And Y equals frequency. And if I run that, then now instead of having that ugly gray color, we can adjust the color so that it looks better. And again, experiment with the bin width until it looks right to you. Again, the rules about histograms basically is there's a rule of thumb, and then different data sets will give you different shapes, and you want to sometimes experiment with it until you get a graph that you think looks like it's not overly binned and not too jagged, but relatively smooth and can actually show the results of the data without being, sort of the bins being too big and then not giving you enough detail. And then we can also very easily make a normal probability plot, which can be useful for assessing normality. There is, of course, a way to do that in the regular base graph, but we can also do that in ggplot, QQ, and then AES, sample equals det. And of course, normally in a QQ plot, you would want to also impose a line on this. You can do that by simply adding another geom, like geom line or something like that, in order to add that line that you're trying to fit for the QQ plot to the data. Now, one other thing that is extremely important, particularly for base graphs, is that sometimes you want to have graphs that plot side by side. And the way to do that is with the function par mf row equals C12. Now this is going to specify that you have one row with two graphs side by side, and then the next two graphs that you create will plot on the same window here next to each other. Now, this can be very helpful, especially if you're doing you can make this 2 by 2 if you want to plot a 2 by 2 grid of graphs. So if you're doing comparisons with different variables, this can be very, very handy. But when you're done with it, it's going to persist until you turn it off. So if you run this function, I'm not going to, because then I'd have to turn it off. But when you run this function, it'll persist until you turn it off. So when you want to turn it back off again, rerun this command, but with with 1 and 1 in it. So it'll be a 1 by 1 graph every single time. That is the default setting. But as I said, if you run this and you alter that configuration of how many graphs are plotted side by side, then it'll stay that way until you restart R and clear the environment, or until you actually turn it back off again and reset this to C11. All right.